Hello students, in this video we will discuss about the previous year NEET chemistry questions. Let us move on to the first question. Identify the compound X in the following sequences of reaction. So here methyl benzene reacted with chlorine in presence of light, it produces X, then it undergo hydrolysis in with 373 Kelvin, it gives benzaldehyde. So it comes under branch of organic and the type of reaction is substitution reaction. Substitution reaction. So first methyl benzene reacts with chlorine 2. So it gives dichloromethylbenzene. So dichloromethylbenzene. So here removal of 2 HCl takes place and it produces dichloromethylbenzene. So it further undergoes hydrolysis. So produces highly unstable molecule is COH here H, which is highly unstable. Further removal of water takes place and it gives aldehyde. So here intermediate is dichloromethylbenzene. So the compound X is dichloromethylbenzene. So the correct answer is option number 1. Move on to the next question. Which of the following is a natural polymer? Natural polymers are always cis isomers. So the correct answer is option 3. Next, move on to the third question. The calculated spin only magnetic moment of chromium 2+ is. So here the atomic number of chromium is 24. So let's rewrite the electronic configuration of chromium 2+ is 1s2, 2s2, 2p6, 3s2, 3p6, 3d4. So the number of unpaired electron is 4. So we know the equation for magnetic moment is mu is equal to root of n into n plus 2. So n is number of unpaired electron, mu is the magnetic moment. So we substitute the 4 in the above equation. So 4 plus 2. So the root of 24 Bohr magneton. So the root of 24 is 4.90 Bohr magneton. So in some cases they are not giving a calculator in some competitive exam and all. So to save time, now I give a data which it saves your time. So for n is equal to 1, that is when unpaired electron is 1, the mu value is 1.73 Bohr magneton. So when unpaired electron is 2, the magnetic moment is 2.82 Bohr magneton. When unpaired electron is 3, magnetic moment is 3.87 Bohr magneton. So number of unpaired electron is 4. The magnetic moment is 4.89 Bohr magneton. So n is equal to 5. mu value is 5.91 Bohr magneton. So the correct answer for chromium 2 plus is option 4. Next, move on to the fourth question. Urea reacts with water to form A, which will decompose to form B. B, when passed through copper 2 plus aqueous, D blue color solution, C is formed. What is the formula of C from the following? So, here first urea. Urea is NH2CONH2, which reacts with water, gives ammonium hydroxide, that is NH4OH, and releases carbon dioxide. So here the compound A is ammonium hydroxide. So this compound A further decompose to give, which gives ammonia and water molecule. Generally, decomposition means this is a reaction in which compounds breaks down into two or more simple substances. So ammonium hydroxide undergo decompose and produce ammonia, which is B, and water molecule. So further this ammonia is passed through, so I write down here, this ammonia which is passed through copper 2 plus aqueous solution, it gives copper 2 complex ion, that is copper NH3 the whole 2 plus, copper 2 complex ion. Here ammonia is Lewis base which donates its pair of electron. Here copper 2 plus is electrophile which accepts its pair of electron and form a copper 2 complex ion, which is a deep blue color. So the final product is copper 2 complex ion. So the correct answer is option 4. Let's move on to the fifth question. The number of sigma and pi bonds in pent-2ene-4ene is. So first let us draw the structure of pent-2ene-4ene. So the structure of pent-2ene-4ene is CH triple bond C, CH double bond CH, C, H, H, H. Now you can easily answer the given statement accordingly. So it contains 10 sigma bonds, 10 sigma bonds, that is 6 CH bond and 4 carbon single bond C, carbon carbon bond. So total number of sigma bond is 10, and here you can see there are 3 pi bonds. So one is 3 pi bonds. So that is one is from one pi bond is from carbon double bond carbon, and another 2 pi bonds from carbon triple bond carbon. So number of pi bond is 3. So the number of sigma and pi bonds in pent-2ene-4ene is 10 sigma bonds and 3 pi bonds. So the correct option is 3. So let's move on to the sixth question. If the rate constant for a first order reaction is K, the time T required for the completion of 99% of the reaction is given by. So we very well know first order rate constant is K is equal to 2.303 divided by T log of A by A minus X. So the complete reaction is considered as 100%. So the given completion of the reaction is, that is, X is equal to 99%. So A minus X is 100 minus 99, that is 1%. So for 99% completed reaction, the rate constant K is K, which is equal to 2.303 divided by T log 100 by 1. So we can write this as 2.303 T log of 10 square so we can write this equation as 2.303 T 2 log of 10. We very well know log 10 is 1. So 2.303 divided by T into 2. So 4.606 divided by T. So we need the time required for the completion of the reaction. So the time required for this reaction is T is equal to 4.606 divided by K. So the correct answer is 4.606 divided by K. So the option number 1 is correct. Next, move on to the 7th question. The manganate and permanganate ions are tetrahedral due to. So generally tetrahedral is a shape that results when there are 4 atoms or no lone pair electrons around the central atom in the molecule. So which possess tetrahedral shape. So here we see the structure of manganate. First we take manganate. The structure of manganate is that is MnO4 2 minus. The oxidation state of this manganate is +6. So we draw the structure of this M and double bond O minus, here O minus. So next move on to permanganate, that is MnO4 minus. Here the oxidation state is +7. So we draw the structure of permanganate is Mn double bond O, here O minus. So here the bonding, here in both cases the bonding takes place by overlap of p orbitals of oxygen and with d orbitals of manganese. That here the pi bonds are d pi to p pi type. So as well as in permanganate, here the pi bonds are d pi to p pi type. So in both cases the bonding takes place by overlap of p orbitals of oxygen with d orbitals of manganese. So the correct answer is option number 3. That is, the pi bonding involves overlap of p orbitals of oxygen with d orbitals of manganese. Next, move on to the 8th question. pH of a saturated solution of calcium hydroxide is 9. The solubility product of calcium hydroxide is. So here they given the pH of calcium hydroxide and you want to determine the solubility product of calcium hydroxide. So we want to write the equilibrium of calcium hydroxide. So equilibrium of calcium hydroxide is calcium hydroxide, which is equilibrium with calcium 2 plus aqueous plus 2 OH minus aqueous. We can write down this as solubility product of Sp. That is, here this one is S, this one is 2S. Next, we have write the specific name of equilibrium concentration, that is Ksp. We write down as equilibrium concentration. Ksp is equal to K calcium 2 plus concentration and OH minus concentration square. This one is coefficient. So here the 2 is coefficient. So now we have pH, which is equal to 9. We know pH plus POH, that is 14. So we know pH is 9. So POH is equal to 14 minus 9, that is 5. So we know POH, which is equal to minus log of OH minus ions. So which is equal to 5. So negative log of concentration of OH minus ion is POH, that is POH is equal to minus 5. So now we write power of 10. So power of 10. So 10 to the power of log OH minus, which is equal to 10 power minus 5. So now we know. So here the property we need to apply is 10 to the power of log x, which is equal to x. So concentration of OH minus is 10 to the power minus 5. So now we come to the equation. So here 2s, here OH minus is 2s, so 2s is equal to 10 to the minus 5. So s is equal to 10 to the power minus 5 divided by 2. So let us come to the equation, that is Ksp is equal to concentration of calcium 2 plus into concentration of OH minus ion power of 2. So here we write down as S into, here OH minus is 2S the whole square. So we know S is 10 to the power minus 5 divided by 2 into, so here 2s is 10 to the power minus 5 the whole power 2. So here the final answer is 0.5 into 10 to the power minus 15. So the correct answer is option 3, that is the solubility product of calcium hydroxide is 0.5 into 10 to the power minus 15. Next, move on to the 9th question. A mixture of 2.3 gram formic acid and 4.5 gram oxalic acid is treated with concentrated sulfuric acid. The evolved gaseous mixture is passed through KOH pellets. Weight in gram of the remaining product at STP will be, that is STP means standard temperature pressure, that will be. So first we write down the equation. First we take formic acid, that is HCOOH, which treated with concentrated sulfuric acid. Here sulfuric acid is a strong dehydrating agent. So sulfuric acid undergoes treated with concentrated sulfuric acid, which gives carbon monoxide plus water molecule. So next we take oxalic acid, that is COOH, the whole 2, which treated with concentrated sulfuric acid gives carbon monoxide plus carbon dioxide plus water molecule. So here first we calculate the moles of formic acid, that is moles of formic acid, which is equal to, so here the given formic acid is 2.3 gram divided by the molecular weight of formic acid is 46 gram per mole. So the mole of formic acid is 0.05 mole. Next come to moles of oxalic acid. So the given is 4.5 gram. The molecular weight of formic acid is 90 gram per mole. So the final thing is 0.05 mole. So from equation 1 we get number of carbon monoxide form is 0.05 mole. From equation 2, number of carbon monoxide formed is 0.05 mole. Here the formed carbon dioxide absorbed by KOH pellets, and the water molecule absorbed by sulfuric acid, that is H2SO4. So the remaining product is only the carbon monoxide. So hence the total number of carbon monoxide formed is 0.05 plus 0.05, which is equal to 0.1 mole. So thus the weight of the remaining product is weight of remaining product, that is weight of remaining carbon monoxide is 0.01, which is mole into 28. This one is a molar mass of carbon monoxide. So 2.8 gram. So the remaining product is, which is equal to mole into molar mass. Here the number of moles of carbon monoxide is 0.01 and the molar mass is 28. So the net weight of remaining product is 2.8 gram. So the weight of the remaining product is 2.8 gram. So the option is 2.8 gram. Next, come to the 10th question. Carboxylic acid have higher boiling points than aldehydes, ketones and even alcohols of comparable molecular mass. It is due to their. So first we write down the structure of carboxylic acid. So RC double bond O, here OH. So we can write down this side. So RCOH, here double bond O. So the interaction between O and H is hydrogen bonding. So the molecules of aldehyde and ketone are associated to each other by weak dipole-dipole interactions, where acid and OH group, they are associated due to extensive intermolecular hydrogen bonding. Intermolecular hydrogen bonding. So in this case of boiling point, the boiling point of aldehyde and ketone is less than the boiling point of acid of comparable molecular masses. So mainly, that is, carboxylic acid have higher boiling point than other functional groups is mainly due to more extensive association through intermolecular hydrogen bonding. So the correct answer is option 4, that is formation of intermolecular hydrogen bonding. Let's see the next question. Following solutions, they gave some solutions were prepared by mixing different volumes of sodium hydroxide and hydrochloric acids of different concentrations. The pH of which one of them will be equal to 1. So depending on the concentration, the resulting solution may acid or base. So here, among all the given concentrations of acid and base, acid is left at the end of the reaction. So we come to know that N1V1 greater than N2 V2. So resulting solution will be acidic. So the equation will be N, that is final solution of H plus ion concentration, which is equal to N1V1 minus N2V2 divided by V1 plus V2. So among all the given values, the option C is correct answer. Now we substitute this all the values in the following equation. So here N1 is, that is normal, N1 is normality, V1 is the given volume. So here the N1 normality of hydrochloric acid is here 1 by 5, the volume is 75, minus 1 by 5, the volume of sodium hydroxide is 25. Now we know the volume of first hydrochloric acid is 75 plus volume of sodium hydroxide is 25. So this comes to 1 by 10, which is equal to 0.1. So here we want to calculate the pH. So pH of this solution can be calculated using the formula pH is equal to minus log of H plus ion concentration, which is equal to 1. So the final, so as it is left at the end of the reaction. So the correct answer is option 4, that is the concentration of sodium hydroxide and HCl would be the option C. So let's move on to the next question. Which of the following carbocation is expected to be more stable? So here we see the nitro group, which shows electron withdrawing minus I effect. So here the carbocations directly attached to the nitro group are highly unstable. So as we can see in the options 3 and option 4 are highly unstable. So in option B, here after resonance also the carbocation formed is directly attached to the nitro group, so it is also unstable. So I will show you. So for option 2, here the nitro group is a meta-directing group, so we write down the resonance. So YH, here the carbocation is, so nitro group here. So it undergoes resonance and form, so Y here H, here nitro group. So here this bonds goes to the ortho position and forms the carbocation in the direct nitro group. So after resonance also the carbocation formed is directly attached to the nitro group, so it is less stable, which is mainly due to the electron withdrawing effect of nitro group. So in case of option 1, so the carbocation is at the para position with respect to the nitro group, and even after resonance the carbocation forms at ortho position only. So thus the most stable carbocation is option which is shown in option 1. So I will show the resonance. So here the carbocation is at the para position with respect to the nitro group. So here it undergoes resonance where the bond goes here, so and form the carbocation in the ortho position. So it comes like this. So it again undergoes resonance and form a stable compound. So which one is the option 1 is most stable due to less electron withdrawing effect. So the correct answer would be option 1. Let's move on to the next question. Which one is the most acidic compound? So here we see the nitro group. Here the nitro group in first option. Here the nitro group which is a electron withdrawing group and which has very strong -I and -I effect. So the compound will show more acidic nature. So the order I will show the order of acidity for the given compounds are: first highly acidic compound is option 1. So next acidic compound is option number 4, para-nitrobenzyl alcohol. In third position, the compound is benzyl alcohol, and option 3 comes in the fourth. Option 2 comes in the fourth position. So comparing all the 4 given options, option number 1 is the correct answer. So next, move on to the next question. Match the interhalogen compounds of column 1 with the geometry in column 2 and assign the correct code. So they give column 1 some interhalogen compounds. In column 2 they give geometry. So we want to assign the correct code. So here we see column 1. So the first XX, it corresponds to linear. So that is option 3. So next, in column 1, this interhalogen compounds belongs to T shape, that is sp3d. So come to the third one. In column 1, it corresponds to square pyramidal, that is sp3d2 configuration. So next comes to the xx7 dash. So it comes to the pentagonal bipyramidal. So this one is sp3d3. So let's see the options. So here linear comes. So the correct option will be option number 1. So next, move on to the next question. Concentration of silver ions in saturated solution of Ag2C2O4 is 2.2 into 10 to the power minus 4 mole liter inverse. So solubility product of the given compound is. So we write down the equilibrium equation of Ag2C2O4. So the equilibrium equation is 2 Ag plus, which is in aqueous, so plus C2O4 2 minus. So let's write down the solubility product. So the solubility product is KSP of Ag plus, which is equal to, that is the concentration of Ag plus ion in a saturated solution is 2.2 into 10 to the power minus 4. So therefore C2O4 2 minus, which one is 2.2 into 10 to the power minus 4. This one is Ag plus, which multiplied by 0.5. So the solubility product of Ag to C2O4 is 1.1 multiplied by 10 to power minus 4 mole liter inverse. So the correct answer is, so next we want to substitute these two values in the equation, that is equilibrium concentration equation, that is Ag plus square, here C2O4 2 minus. So substitute these values, that is this value and this value. So Ag plus is, the solubility product of Ag plus is 2.2 into 10 to the power minus 4 multiplied by concentration of C2O4 2 minus is 1.1 into 10 to the power minus 4. So the product is 5.3 into, so here square, so the product is 5.3 into 10 to the power minus 12. So the correct answer is option number 3. The solubility product of Ag to C2O4 is 5.3 into 10 to the power minus 12. So let's move on to the next question. A first order reaction has a specific reaction rate, that is 10 to the power minus 2 second inverse. How much time it will take for 20 gram of the reactant to reduce to 5 gram? So we know the half-life of first order reaction is, half-life of first order reaction is T half is equal to 0.693 divided by K. So here we know the rate, reaction specific reaction rate, that is 0.693 divided by, here the specific reaction rate is 10 to the power minus 2. So the half-life period should be 69.3 seconds. So here we can calculate the time that it will take for 20 gram of the reactant to reduce to 5 gram. So here we use two methods. So I will show the first method. So that is method 1. So here we see, here the 20 gram of reactant is reduced to first 10 gram. So this is half-life of first, and this 10 gram is reduced to 5 gram, which takes to second half-life period. So the total time to take reduce 20 gram to 5 gram is 2 T half, which is equal to 2 into 69.3. So here 2 multiplied by 69.3 is 138.6 seconds. So this one is the first method to know the time that will take for 20 gram to reduce to 5 gram. So the second method, method 2, that will be, we know the rate constant, first order rate constant equation, that is T is equal to 2.3 divided by K log of A naught by A. So here we A1. So here very well know 2.303 divided by the rate constant value is 10 power minus 2 log of here A naught is 20 gram divided by A1 is the amount, how much amount it will reduce, that is 5. So the final answer, that is T, the time take for 20 gram of the reactant to reduce 5 gram is 138.6 seconds. So the correct answer is option number 1. Next, move on to the 17th question. The rate of first order reaction is 0.04 mole liter inverse second inverse at 10 seconds and 0.03 mole at 20 seconds after initiation of the reaction. So they gave the rate constant for 10 seconds and the rate constant for 20 seconds. So we want to determine the half-life period of the reaction. So the rate law expression for the first order reaction is the rate of first order reaction is K, that is rate constant of A. So we substitute all the values in the above expression. So if we substitute the values in the above expression, so the rate constant 0.04, which is equal to K of A of here 10, this is for 10 seconds. So as well as for 20 seconds, the rate constant is 0.03, which is equal to K A of 20. So this one is equation 1, this one is equation 2. So divide equation 2 by equation 1 by 2. So we have A of 10 divided by A of 20, which is equal to 0.04 divided by 0.03, which is equal to 4 by 3. So half-life period, that is at 10 seconds, the expression for the rate is, we know the equation here, T is equal to 2.303 divided by K log of A of 10 divided by A of 20. So here we know the value of T. So that is 10 seconds, which is equal to 2.303 K log of A of 10 is 4 divided by A of 20 is 3. So we bring upon the K value in this side. So K is equal to 2.303 divided by 10 log of 4 by 3. So the value of K is 0.0288 second inverse. So we want to calculate the half-life period of the reaction. So the half-life period is T half is equal to 0.693 divided by K. Here the rate constant value is 0.693 divided by 0.0288. So which is equal to 24.1 second. So the half-life period of the reaction is 24.1 seconds. So the correct answer is option number 1. So let's move on to the next question. Natural rubber has. So the correct answer is option number 1, because Generally, the natural rubbers are all 6 configuration. So next move on to the 19th question. That is, lithium has a BCC structure. Its density is 530 kilogram and its atomic mass is 6.94 gram per mole. Calculate the edge length of a unit cell of lithium metal. So let's write down all the given values. So density D, which is equal to 530 kilogram meter power minus 3, that is meter cube. So we write down in centimeter, that is 0. Kilogram per centimeter cube, 0.530 gram by centimeter cube. So we know that 1 kilogram per meter cube, which is equal to 10 to the power minus 3 of gram per centimeter cube. So here molar atomic mass is m, that is which is equal to 6.94 gram per mole. So for BCC unit cell, the number of atom per unit cell is 2. So here we know the well-known equation, density D, which is equal to atoms per unit cell into molar atomic mass divided by A cube, that is Avogadro number. So density is 0.530, which is equal to 2 into 6.94 divided by A cube into 6.023 into 10 to the power 23. So A cube, which is equal to, that is edge length, so which is equal to 4.34 into 10 to the power minus 23. So calculating A value, which is equal to 3.52 into 10 to the power minus 8 centimeter. So the edge length of a unit cell of lithium metal is, that is A is equal to 352. So the correct answer is option 2. So next move on to the 20th questions. Equal moles of hydrogen and oxygen gases are placed in a container with a pinhole through which both can escape. What fraction of the oxygen escapes in the time required for 1/2 of the hydrogen to escape? So as we learn in concept, that is Graham's law of diffusion, we know. So according to Graham's law of diffusion, the equation is n1 divided by n2, which is equal to root of m1 by m2. Here we write down r, which is equal to n. Here it indicates rate of diffusion of gas and m indicates the molar mass. So by Graham's law of diffusion of a gas, so for gas, according to Graham's law, the equation should R1 divided by R2, which is equal to root of m2 by m1. So here the r1 we write as r of hydrogen, that is rate of diffusion of hydrogen, and the rate of diffusion of oxygen, the molar mass of, so here the molar mass of m2 indicates the molar mass of oxygen divided by molar mass of hydrogen. So we know the value of molar mass of oxygen, that is 32, and molar mass of hydrogen is 2. So the root of 32 by 2 is, which is equal to 4. So the rate of diffusion of hydrogen divided by rate of diffusion of oxygen, which is equal to 4. So we know, so we need the fraction of oxygen that escapes in time required for 1/2 of the hydrogen to escape. So we know the fraction of oxygen that which escapes. So we write down this as RO2 divided by, so RH2, which is equal to 1 by 4. We know here 1/2 of the hydrogen will be escaped. So we write down RO2 divide by 0.5, which is equal to 1 by 4. So we know the fraction of oxygen that escapes in 1/2 of the hydrogen, so is 1 by 8. So the correct answer is option 1, that is the fraction of oxygen escapes is 1 by 8. Thank you.